Hi, everybody. Welcome to SciDome at Home. I'm going to wait just a couple more minutes and make sure that everybody arrives before we get started on the program. You can take this minute to brighten your screen. A lot of times we have our screens turned down because we're spending so much time on them recently, but brighten your screen. It will help you see some of the stars better. And also, if you want to turn on your chat feature, I'll try to take some questions via chat throughout the program, and then certainly at the end of the program too. I'm going to mute myself again, and we'll get started here in just a minute. Hi, everybody. Welcome to SciDome at Home. My name is Suki. I'm an educator here at the Works, and we'll get started in just a couple of minutes, but a couple of quick things. If you have your screen turned down, the brightness turned down, I recommend turning the brightness up a little bit. It will help you see the stars a little better. And then also, if you want to turn on your chat feature, I can try to take some questions during the SciDome show, and I'll certainly take them at the end too. And our topic today will be Mars, which I'm completely excited about. So how about we go ahead and get started? All right, for those of you that are new to SciDome at Home, I want to take just a second to show you what you are looking at. So this is a flat view of our SciDome. And so I want you to think about that in that you're looking through a fisheye lens. So you can see the horizon is at the bottom. The cardinal directions are written on the bottom. And if you pretend that you're standing on the ground, remember that you're looking all the way up overhead. Like imagine if you were standing on the ground and you had your head tilted back just as far as it could go. That's how high up you're looking. So this fisheye view is what you're looking at to help you get a better perspective of the stars. I have the time set at about 8:30 tonight. We are looking south, as you can see by the cardinal directions. We'll take just a brief minute to look at our winter sky before we head to Mars. So right now, Mars is the only planet that we can see actually. And it's up by our little quarter moon up there, half moon, I guess. It does shine red in our sky. And we'll get to that in a little bit. It is going to be up the entire rest of the spring. So if you don't get a chance to see Mars here in the next few days, I swear I haven't seen any stars in weeks. It's been so cloudy. But Mars will be up until mid-July. So you'll have a chance to see Mars. And what an exciting time we've had with planets. So we can see 5 planets from Earth, but Venus and Mercury are coming up with the sun right now, so we can't see them. And Jupiter and Saturn, which were magnificent through the fall and early winter, they're now below the horizon. So Mars is our only planet that's up right now. Let's take a quick look at a couple of the winter constellations because they're just the best. The easiest winter constellation to find is Orion the Hunter. And he is up all winter long. His belt is the easiest thing to find in the night sky. This flat version of our SciDome doesn't do Orion justice in the winter sky. He's just huge, and that belt really stands out. And you can use that belt to point you up to this V in the sky. And that V is Taurus the Bull. And right now, because remember, the moon won't stay there, this is a great way to locate Mars because Mars is very near Taurus. So you can see Orion's belt points you to Taurus. And then this is little Pleiades, this little cluster of stars, the 7 sisters, Pleiades. And then look for little red Mars, sort of below Pleiades in the night sky. And that will help you find it. Then you can use Orion's belt to point the other direction. And this star, Sirius, is the brightest star in our night sky. The moon is the only thing brighter in our night sky to Sirius. And that's the nose of Canis Major. So you can think of Canis Major, Orion's hunting dog, and he's chasing Lepus the bunny rabbit, by the way, through the night sky. He'll never catch him though. So use those fabulous winter constellations to help you find Mars. So now, very exciting news, of course, about Mars. Hopefully everybody heard that NASA landed Perseverance, the rover Perseverance, successfully on Mars today at around 4 p.m. Very exciting. So let's take just a minute to learn a little bit about Mars. Now I'm going to try this feature, this go there, and we'll see if this works or not. And we'll fly to Mars, whoop, past the moon. There we go. So now we're looking at Mars from about 13,000 kilometers away. So Mars really is red. It's named after the god of war. And it is red because it's basically covered in rust. It's covered in iron oxide. And so when the sun reflects off of Mars, it reflects as red. Mars has 2 little tiny moons Phobos and Deimos, which, by the way, are the names of the son of the Greek god of war. But they are very tiny. One of them is about 6 miles across. One of them is about 3 miles, and they're irregularly shaped. So it's thought that Mars's 2 moons were actually asteroids from the asteroid belt that Mars gravity pulled in to them. And if you were to stand on Mars, they would actually appear very small in the sky, like kind of the equivalent of Venus in our sky. They would just look like one of the other stars. They're not big like our moon is to us. So Mars has some other pretty interesting things. For instance, it has a very minimal atmosphere. It only has 1% density of Earth's atmosphere. So with that, it doesn't hold heat very well. So the temperatures can fluctuate from 100 degrees below zero at night to 30, 40 degrees during the day. So those are pretty harsh conditions for the rovers to be on. And we have had several rovers on Mars. Let me see if I can pull up. Here's a picture that I took from NASA. Now think of this. This is Mars flattened out, okay? So you can think of it that way. Spirit, Curiosity, and Opportunity might be 3 rovers that you are familiar with. Curiosity is the only rover that is still functioning. Now, with that said, all 3 of them were only supposed to last about 90 days. And all of them lasted much longer than that. And in fact, Curiosity's been going since 2012. So we're still getting some images back from Curiosity. InSight is right here. InSight landed on Mars a couple of years ago, but InSight stays stationary. It's not a rover. It's taking different information, seismic activity, things like that on Mars. It's trying to learn more about the internal structure of Mars. And then we have Perseverance, which landed today in Jezero Crater. And Jezero Crater is thought to be an old lake bed. And one of the main reasons that Perseverance is on Mars is to try to find out if there's any past microbial life that was left behind in this. There's clearly a river delta lake bed going on in this Jezero Canyon. So that's one of the things that Perseverance is trying to learn about. Another thing that I think is pretty interesting is that Perseverance has some tools on it where it is testing oxygen production. So trying to change the CO2 atmosphere of Mars into just oxygen, kind of a precursor to see if humans can use that kind of equipment if we land on Mars. NASA is planning a manned mission to Mars. Also, Perseverance is going to collect samples and save them in little tubes that can hopefully be sent back to Earth with future missions. I have a quick little video that I think is, it's from NASA, JPL, and I'm find it to be really insightful. So I'm sure that I could have gone about this a better way, but I'm going to do it this way. And we will try to watch this. And it's about landing on Mars, what it takes to land on Mars.
Nothing can be taken for granted when you get to Mars. There's a lot of things we just don't know.
Space always has a way of throwing us curveballs and surprising us. Until we get the data that says we're on the ground safely, I'm going to be worried that we're not going to make it. Entry, descent, and landing is often referred to as the 7 minutes of terror, because it takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
The spacecraft has to do all of this by itself.
There are many things that have to go right to get Perseverance onto the ground safely.
There's a lot counting on this. This is the first leg of our sample return relay case. There's a lot of work on the line. Starting about 10 minutes before atmosphere entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come screaming in to the Martian atmosphere at 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere, sort of like transforming vehicle that went from spacecraft and now kind of an aircraft actively guiding itself.
When we're going slow enough, we deploy a parachute.
Biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
Perseverance's entry, descent, and landing borrows heavily from that of Curiosity.
But fundamentally, Perseverance is a different rover. Bigger, she has different instruments.
We've added a lot of parts on the inside to make it more capable so that it can deal with the landing site that we've given. The science team identified Jezero Crater as basically an ancient lake bed and one of the most promising places to look for evidence of ancient microbial life and to collect samples for future return to Earth. The problem is it's a much more hazardous place to land. You look at Jezero, all you see is danger. How do we go to a site that we never thought was safe enough to go to before? The heat shield, which has protected us all the way through entry, is no longer necessary. We need to get that off so that we can actually see the ground. And we can see the ground in a couple different ways.
Perseverance will be the first mission to use terrain relative navigation. So while it's descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. This is finally like landing with your eyes open. Having this new technology really allows Perseverance to land in much more challenging terrain than Curiosity or any previous Mars mission could. Amongst the rocks, the craters, the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, jettison the back shell and parachute and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky crane maneuver. Once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. Surviving that 7 minutes is really just the beginning of Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
I highly, highly, highly recommend, if you have any interest in learning more about Perseverance, go to NASA's website. They have all kinds of information and videos that are amazing. But I like that video because I think it really does a good job of explaining how Mars's atmosphere is thin enough that it's difficult to use things like regular parachutes. But it's also thick enough that you do need a heat shield. And on the note of Mars's atmosphere, there's a new instrument that's going to be on this rover. Ingenuity is actually a little helicopter. This is going to be the first flight, vehicle with flight on another world. And Ingenuity is an amazing little helicopter that is definitely worth looking into if you have any interest in learning more about it. Definitely go to NASA. It is an amazing technological feat for sure. But I wanted to talk a little bit about Mars in relation to Earth and our other very close neighbor that you might be familiar with, Venus. So to compare sizes, I'm going to back up just a little bit. Here's our beautiful Earth from about 35,000 kilometers away. Here's Venus. Venus and Mars are about the same distance from Earth when they're at their closest to us in orbit, obviously, about 40 million miles away. So Venus is about the same size as Earth. And in our night sky, Venus can look very bright. It is a large body, size of Earth, but also its atmosphere is very reflective. So when we see Venus in our night sky, it looks very bright because of those two things. So again, Venus and Earth are about the same size. And then you can see Mars from that same distance, that 35,000 kilometers away. Mars is about half the size. And again, when the sun reflects back to us off of Mars, it looks red in our night sky. So how about if we go ahead and land back on Earth? I'll pull the horizon down a little bit for us here. So when we stand on Earth and look at Mars right up here, I want you to think about too that it takes 7 months to travel to Mars with our current technology. So all those scientists that you saw in that video have been working on Perseverance for a decade. They put it all together and then they have to send it up into space and wait for 7 months and hope that it lands safely, which I'm so excited that it did today. And one thing that I think is interesting is that NASA's planning a manned mission to Mars. So I just want you guys, everybody out there, to think about, that trip that you've taken to the Outer Banks where it took about 12 hours in a minivan, and maybe you were the parent or maybe you were the kid in the minivan and you had to just power through the whole 12 hours. You weren't stopping, like maybe one time for gas and that was it. Imagine being in a minivan for 7 months as you travel to Mars. I hope that somebody out there wants to do that because I just think it sounds amazing. So one last time, we'll point out Mars. We'll point out some of our favorite winter constellations. And then we'll head over to the north sky. Oh, let me turn the illustrations on. And we'll just take a quick spin around It's easier to spin it around this way. And we'll take a quick look at the north sky before we finish up. So when we look north, can everybody find the Big Dipper? That's the easiest thing to find in our north sky. But it's actually part of Ursa Major. And you can use the Big Dipper and Ursa Major, use these two stars to point you to Polaris, or the North Star, which is the tip of the tail of Ursa Minor. And if I run time forward, keep an eye on the North Star. See how the North Star stays still? Looks like all the other stars are moving around it. Remember, that's actually the Earth rotating on its axis. It's just that our North Pole axis is pointed right at Polaris. So that's why Polaris seems to stay still in the sky. I'll stop time here. And I'll go ahead and turn on all of the constellations. You can see Draco the dragon is curled around Ursa Minor. Cassiopeia, this squished W or squished M, is an easy constellation to find. And with all the constellations on, I'll rotate around. By the way, this is at about 2:30 in the morning. So Orion and Taurus are about to go below the horizon. Leo the lion, which I think of as a spring constellation, is up in the sky. You can find that backwards question mark in the night sky. And did you know there's a unicorn in the night sky? It's actually not very easy to see. It's a kind of right above Orion, but not actually that easy to see. All right. Well, that is what I have for you this evening. I don't know if anybody has any questions at all. You're more than welcome to ask them in the chat feature. And I will be happy to try to answer them for you. Somebody asked, do you know it's Pluto Day? No, I did not know that it was Pluto Day. But I will look that up. Oh, somebody asked, what is the name of the giraffe constellation? Yes, it's very funny, and I'm probably going to not pronounce it very well. Camelopardus, and it's, first off, this little thing does not look like a giraffe to me, but I think it is supposed to be like a camel leopard. A lot of these, almost all these constellations were named by Ptolemy about 2,000 years ago. So most of them are Greek and Roman mythology, and they don't necessarily really look like pictures in the sky, right? Somebody asked, what is the deepest crater on Mars? And I just looked it up because I didn't know it off the top of my head. There's an impact crater that is 23,000 feet deep, 7,000 miles deep. Oh my goodness. That's enormous. Is there any water on Mars? Yes, from what I understand, there is frozen water at the poles of Mars. So you know how on Earth, the North Pole and the South Pole both have are permanently frozen, although I feel like Ohio is permanently frozen right now, but Mars also has frozen water at its poles. And I believe that there are some really deep craters that have some frozen water in the shadows. And I know that that's one of the things that Perseverance is doing as well, is trying to test for, sorry, my phone just rang, of course, trying to test for water. Does Mars have mountains? Yes, Mars has lots of mountains. And in fact, one of the rovers, boy, I feel like it was Spirit, was able to go up one of those mountains. If you go onto NASA.com and look at their Mars missions, you will be able to see some amazing panoramic pictures of some of the mountains. I tried to, they didn't show up on my screen very well for this show because I was going to show you some panoramic pictures, but they're quite tall from what I understand. That's what, yeah, somebody is saying that one of the mountains on Mars is bigger than Mount Everest. I know I have read that before. They're probably not all that tall, but I know that one of them at least is. And then somebody asked if Mars is tilted on its axis. And yes, it is. It's very similar to Earth. Earth is tilted at 23 degrees, and I think Mars is tilted at 25 degrees. So it has seasons similar to Earth. Now, with that said, you know, with little atmosphere, the heat doesn't stay, but it does create weather patterns, the dust storms, things like that. Somebody asked how long is a year on Mars? So a year is a revolution around the sun. So Earth, 365 days to go around the sun one time. Mars actually takes 687 days to go around the sun. Also too, so Earth takes 24 hours to rotate once on its axis, and Mars, I believe, takes an extra hour. So if you ever read like a SOL, SOL, a Mars SOL, that's the equivalent of their of their day. And what is gravity like on Mars? Gravity is 38% of Earth. So that's another thing with the little helicopter Ingenuity, very little atmospheric pressure and not a lot of gravity. So NASA had to, this thing is so magnificently engineered, it's really worth checking out. Oh, 24 hours and 37 minutes to be exact, I believe is a day on Mars. And I have to say, I'm so excited that I hope in my lifetime I get to see a manned mission to Mars. People will be brave enough to go there. All right. Is there lightning and the storms on Mars? Boy, I don't know. The main storms that I've read about on Mars are the dust storms, where huge quantities of dust can move around Mars. And in fact, that's why the rovers, the older rovers, are no longer working, or at least part of the reason is their solar panels got completely covered in a thick layer of dust. And so they weren't able to. Hold on one second. Oh, okay. So thankfully my husband is here with a computer. So he looked it up on NASA, and it does say that the storms might also crackle with electricity. It looks like they might produce hydrogen peroxide, which is interesting. All right. Well, everybody, thank you so much for tuning in. And I do hope that you take some time to go over to NASA and check out Perseverance and Ingenuity. And if you get the chance to watch the landing, I was watching it today at 4 o'clock, and those last 10 minutes, it's really exciting to see everybody so excited at NASA. So, all right. Thank you so much. Have a great night.